Jesus, Energizer Bunny. Firstly, I do have to apologize. We were going to make barista stickers, but then we forgot to sponsor the coffee cart. So, yeah, the B got dropped off. Make it interesting, they said. Gosh, that's always hard at a networking conference. So let's start with some SeaWorld true crimes. Yeah, so this is going to go either really well or really poorly. Dolphins. Who saw the dolphins last night? It was really... Dolphins, they're the victims here. I have some sad news. Dolphins actually don't live longer in captivity. Look it up. That was a really weird stat that they said. Actually, most dolphins in captivity, more than 50% die in the first year. True crime. Okay, so let's go through some of the other things. I didn't have a chance to heckle during the presentation. We'll go through some pretty hard and pretty fast. Where are the Juniper people? They work at Arista. Container Lab. Container Lab rocks. It makes me feel like next year maybe I'll do a talk on, it's called nuts. Nuts or vein or some form of PyTest, how to test in that environment. I think that would be quite interesting. Telstra, there are such things as remote controlled circuit breakers. So you can check a circuit breaker remotely without having to send a tech to site. CFP2s are old tech, do not use them. Okay, here's a bit of a controversial one. I hesitate to bring it up, but it is true. Why didn't Pornhub turn up in the quick stats? Like, it's a big part of internet traffic. It should have actually appeared in the stats. I'm really surprised, to be honest. Yeah, okay. On a more serious topic, we do have to pay for support. I know that was one of the things that came through in a previous presentation. If you don't pay for support, I swear that we won't help you. And sorry, Tim, but vendors don't have a soul. Welcome to the dark side. Cool. So acknowledgements. This is a presentation that was actually being given in NANOG earlier in the year. It was also, if you're a New Zealander, no, they've left. They've gone back to New Zealand. Yeah, I gave a rough version of this there as well. This presentation does not follow 5737. Sorry, I am just lazy. All content has been generated by a human. Sorry. And Phil said I had to put at least a couple of errors in to keep you sharp. There are different grades of errors. So if you see a small typo, good. If you spot a technical error, you're paying attention. Cool. So what is gRIBI or gRIBI? I'll get to that in a second. It's actually one of Lincoln Dale's inventions. Is he still in the room? I always love it when I talk about something that someone else in the room actually invented. No, he's not. Good. So everything that's wrong with it is his fault. So I'm going to talk through the existing approaches for route injection and why they suck, details about gRIBI, and how that is implemented, and walk through a simple weighted route injection scenario. So firstly, why gRIBI? Well, the reality is that there's a lot of different approaches for injecting routes into a network. About 14 years ago, give or take, some geniuses out of Stanford thought that OpenFlow would be the right idea, and we would just reach directly into the ASICs and jiggle things around and make it do what we wanted. There are other approaches that use routing protocols. Who uses BGP-LU to inject a route into your network? It's not a bad thing, okay? But only 2 people are brave enough to admit. Then maybe we use it for egress peer engineering or other methods. There are device APIs using vendors' SDKs. Anyone use those? 1, 2. Okay, cool. So you can see that the problem here is that largely these techniques are not widely used, and that results in us using CLI. It uses us using policy-based routing, maybe even, dare I say it, static routes. IETF was going to solve this with I2RS, I think, but we're still waiting. So direct programming assumes that, this is not gRIBI, this is the traditional approach, that controllers have a full view of the device's forwarding table, that we can modify all the hardware tables, and if there's differences in the hardware implementation, that the controller somehow knows that, and that if we're using IGP routes in addition to injected routes, that somehow we know the reaction that's going to take place, particularly when there's some form of recursion, and then if the IGP route changes, that somehow the controller will see that, understand the impact, and respond to that. So overall, it just adds complexity to the system. Using a routing protocol involves basically trying to find a way to make BGP do yet another thing. There is no notion of a transactional semantic. You advertise a route in BGP, and you kind of hope that the other side does something with it. And there's no acknowledge if they receive the route. Yep, you can see that because there's a session. Maybe they put that into the RIB. You don't know that it's actually been programmed into the FIB of the receiving device. And vendor-specific APIs, well, they're just not open, and they're not portable, so you have to do this again and again for each vendor that you implement. What about route maps? Who uses a route map? Come on. Yeah, okay. Route maps suck. They're lengthy, they're fragile. There's a high admin burden, you always end up, if you spend a lot of time, if your device or code spends a lot of time in production, eventually you get a longer and longer route maps. You also end up getting confused as to which route map is actually being applied, and you end up with a lot of very similar sounding route maps, which you may accidentally use when you didn't mean to. There are more modern techniques, and because this is a vendor-neutral presentation, I would give a shout-out to EOS RCF, Arista's, iOS XR's RPL, Junos policy language. There are more modern ways that create a more programmatic approach to how you filter and process routing information. You can even treat them like code blocks, which means you can reuse parts of them in multiple different policies. It's a really good idea. So what about gRIBI? It's an RPC service to inject and to query the routing table from a network devices, into a network devices RIB from an external entity, say a controller, or let's just say from software. From a device's point of view, the control plane service where the injected entries, that's just another source. It's just another routing type. If you'd like to go through the motivation of why gRIBI is invented, or was published, I should say. There is a document there. It talks through some of the use cases. I'll give you a bit of a deep dive over the next 27 minutes. Okay, so what is gRIBI? It's in OpenConfig, and sorry Google, it uses HTTP2. They don't use Quick yet. I did check the code. It doesn't, there's lots of comments saying that you should use Quick, but it's still, it's so slow. Yeah, no, it's part of the OpenConfig suite. So obviously you have GNMI for network management, you have GNOI for operations, and there's this other gRIBI for routing information being inserted. Is it an open standard? No, it is a GitHub project. Does that mean that you shouldn't use it? No, you should definitely use it. When we talked about being scrappy in a lot of the presentations, MMC, who's clearly already left, I think that's one of the things that we do always need to remember, that you're not vendor managers, you are network engineers, and that means we need to be able to implement things, and we need to go a little bit scrappy. Maybe not David Teo take light globes out of light sockets to save money, more actually develop new techniques. And that's actually a personal story, by the way. I did work at TPG when David was taking the lights out. So we did have to tell him to put the lights back in. It is not an industry rumor. I got the fine from WorkCover. It's all good. So what's in a name? Well, look, this is Australia. If I say gRIBI or gRIBI, and Lincoln would have been the perfect one to say exactly how he intended that we should pronounce it, but things need to be a little bit more spontaneous in our industry. A few years ago, some people started introducing BPDOs instead of BPDUs. I originally hated, but now have embraced MIPLs. I think that we can get behind that. So, gRIBI is really, it's a little bit of controlled chaos. So just like Gritty from the Philadelphia Flyers, for the rest of my presentation, I'm going to call it gRIBI. All right, let's go. So gRIBI, it's a control plane service. It doesn't look any different from a different type of daemon that sits on your box, and there is a client, an external client, or multiple clients that talk to the gRIBI server and then inject another type of route into the RIB manager, which can then get programmed into the LFIB or into the FIB labels. The data model is based on the abstract forwarding table. Who's heard of AFT? It doesn't matter. It's easy. I'll walk you through it. Now, in terms of the semantics, there's this really important concept, which is that there's these transactional semantics, which means that every communication is going to be associated with a unique ID. That means that when I make a request from a client to the server can respond with the same ID so that I know that the server has actually heard my request and is able to do something with that. This is really important because you want to be assured that something has actually happened. So there's also an acknowledgement of both from a RIB perspective, so have you received this route that am I trying to inject, or you can actually ask to get confirmation that the route has been programmed into the fib. So this is different from basically every other routing protocol injection model where you can have confidence that your route is now actually being used to make forwarding decisions. Other features. So the client itself can be redundant. We can have active standby or active-active for true chaos. Persistence of programmed entries, so we can determine whether a route should stick around if the client goes away or if the device restarts. And as I mentioned, it doesn't use quick yet, so it relies on boring, slow, old TLS and Spiffy. No one said Spiffy yet today, did they? No. Cool. How does it work? So let's go through an example. An example could be that you're trying to inject routing entries into a VRF for scrubbing of DDoS traffic or for DDoS mitigation. So gRIBI is going to inject an entry for another route with its own type and preference, and next hops are going to be recursively resolved in the RIB, just like for every other routing protocol. So we're going to inject a labeled fib entry pointing to a weighted equal cost multipath set of label stacks. So this, if you were thinking about it, could be kind of like a binding SID in a SR policy. Cool. So again, we're injecting a route, not configuration. So this is vendor neutral, and it would look something like this, right? So there is a router we are trying to steer to the scrubber for the destination 100, 100, 101, and we need to essentially bypass the default route. So probably laid the slide out a little bit backwards. So let's start in the bottom right-hand corner. And here we have the next hop entry. So this is that IP and IP tunnel that is going to go from ones to twos. So that's on the left-hand side, ones to twos. That's that tunnel that we're going to create. Then above that, we're going to create a next hop group that uses this new IP and IP tunnel that we've created. So that you can see here, the next hop is weighted to the tunnel 1000. With a weight of 1. Okay, there's only one tunnel here, so we don't have to really worry what the weight is at this stage. And then you can see we're going to create a next hop for prefix 100, 100, 101, and we're going to use that next hop group 1. So the ID from the next hop group of 1 points to the tunnel 1000, which is this tunnel here that we've created. Ta-da! We have now injected a way of creating an IP and IP tunnel to a scrubber for a particular prefix. I thought that was pretty cool. No, sit back down, sit back down. Okay, so MPLS to LSP traffic. Sorry, MPLS traffic. So here we want to do an LSR functionality. So again, starting from the bottom right, here we're going to have, there's 3 different double label that we're going to push. And you can see, 201 300, 401 500, 601 700. I've only included the example here to create the next hop for one of those label stacks. So push label 201, push label 300, so that is the first result. Then presumably we would also include the other 2 possible label stacks, and you can see here in the next hop group with an ID of 1, we're actually going to use weights. So we're going to have a next hop 1000, which is that 201 300 with a weight of 1, a next hop of 2000, a next hop of 2000 with a weight of 2, and a next hop of 3000 with a weight of 5. So this will actually do unequal cost multipath. Okay, so 1/8 will go to the first, 2/8 will go to the second, and 5/8 will go to the third. And then this is applied to the MPLS AFT entry for label 100. So when we see traffic labeled with 100 coming in, we will then unequally spread it using the next hops that we've created. Cool? All right. RPC. So what's the RPC format? What do we use them for? We can use it to modify So we can inject entries, that's a modification. We can change the client parameters, so negotiate the session that we have with the gRIBI server. We can get, so we can ask for information around the current state of the RIB or FIB, or we can flush. Now, warning, flushing is generally, when something has gone wrong. So in terms of modifying, each modify request, it has that ID so that we can trace it back. It has a network instance, which is a fancy way of saying a VRF. It has an operation, add, replace, delete, and then there's the specific entry. Every response has the ID, the RIB or FIB status, and a timestamp, so you can correlate when that action, when that response came back in. Session parameters, so if we wanted to modify the connection, so this is where we set whether or not we want to have an active standby or active-active relationship. It talks about AFT persistence, so whether we want to ensure that this routing entry will persist if the client goes away or if the gRIBI server reloads, or if it should delete. So this is really great for creating ephemeral routes, right? Routes that you want to be there, but at the end of the day, you don't really care if they disappear. So for instance, steering traffic to a scrubber, maybe that's a point-in-time decision. You do care about it for now, but if it wasn't there, would you care? Probably not. Or persistent, you really want to keep that in place. And then there's the ACK. So it could be a RIB ACK, so it's definitely in the RIB, or there's a RIB and FIB ACK, so it's in both. Okay, there is an election process so that there isn't just complete chaos. If you have multiple clients, there is that security methodologies, which I talked about before, I won't go into again. But that way the server actually has an idea of who it should be listening to. In terms of the gets, if I make a GET request, I am going to receive a GET response. The GET request from the client can request all AFT entries from all VRFs, so hey, just tell me everything. Or maybe a specific VRF, so what's in this particular table, or maybe of the specific type, so what do my tunnels look like, or what do my labels look like, and that way you can filter down the information that you're programmatically retrieving, and therefore you don't have to do a filter on the receive side. The device streams entries along with the last RIB and FIB acknowledgement status. So again, when you're looking at what you've actually sent and what you've actually received, it makes it pretty straightforward. Flush. You can flush everything. You can flush a specific VRF if that's what you want to do. Typically, if you really get to a known bad state and you have to start again, I wouldn't, again, this is not something that you should just do every time you want to make a change, but if you get into trouble, it's there. Maybe in a lab environment, that's probably more appropriate. All right, so let's go through a little bit more of a convoluted example here. It's a bit hard to see in the top right-hand corner. I have for a destination of 1.1.1.1. Who was saying that they appreciated all the traffic to that? Was that Tim? There's actually 4 egress paths, Ethernet 2, Ethernet 4, Ethernet too small, 5, Ethernet 6 for 192.168.1.1. So what we're going to do here, and again, I'm not showing everything, but we're going to, again, from right to left, we're going to create next hop constructions that point to that. So actually, we can start from left to right this time just to be a bit different. So there is going to be a persistent entry, and it has a, coming from a client with an election ID of low. And then what you see here is we have index 3 and index 4. So these are 2 indexes of the next hops that we're creating for the address 192.168.1.1. Here we're referencing the outgoing interface of Ethernet 5 and Ethernet 2. Okay, so you can see here we've got 2, 4, 5, and 6. So these are 2 different interfaces for the same prefix. We're adding that as 2 potential next hops. Then we're going to create a next hop group. So in this particular case, you can see in the diagram, the colors have slightly changed. 2 and 5 are going to be one of my load balance pairs. So I'm going to send some of my traffic out those 2 interfaces. And then I'm going to send the other half of my traffic out interfaces 4 and 6. So one next hop group is going to have indexes 3 and... did I make a mistake there? 3 and 4, which are those 2 next hops that I created. And that has a next hop ID of 2. And then you can see here that I'm creating I'm adding for this prefix 1.1.1.1 a next hop group of 2. Okay. I did go through that rather quickly. Hopefully that does make some sense. But you have to work backwards here. I'm creating next hops. So for this prefix on this interface, I take those 2 next hops I've created. I'm creating a next hop group. And then I'm applying that next hop group to a prefix. I would also create a next hop group for interfaces 4 and 6. I'd create next hops for interfaces 4 and 6, then I would create a next hop group for those two egress interfaces, and then I would create another entry here for that particular prefix so that it would load balance across the two. If you look in your routing table, will you see gRIBI introduced routes? Absolutely. So you can see here, there's a G%, and that's how you know. And so for this particular example of 1.1, in VRF default, you can see 1.1 has 2 paths via Ethernet 2 and Ethernet 5. You can see here weights 3 out of 4 and 1 out of 4. Where did we do that? Well, if you actually look in the next hop group construction, we actually gave them a weight of 1 and a weight of 3. 1 plus 3 is 4. Cool. So in the routing table, 3 of 4 and 1 of 4. 3 plus 1 also adds up to 4. It works. Cool. So thinking big picture for a few moments, why does this matter? Why would a vendor get up here and not talk about how great their products are? I'm starting to question that myself. And the reason is because there's a lot of things that we talk about in our industry that are coming. A few years ago, I was fortunate enough to be able to talk here about how we needed to go down the path of EVPN and how we need to go down the path of SR. Who remembers that? Because you're probably too old. Yeah, but it was like, things are moving. We need to get on board. We've done those things. Now we can build SR networks. Cool. Then we want to scale those SR networks. We want to connect those SR networks together. I will tell you, and it's not controversial, other vendors have different ideas about how we should do that. And so one vendor, we won't name them, they think that there's a thing called BGP classful transport, and that would be a way that you express colors between multiple domains. Another one's, classful transport, I don't personally understand why they use that term. Another one said we'll use color-aware routing. Cool. I have talked to Australian operators about what they plan to do, and they're saying, well, you know what, we're not really sure. What do you think we should do? I said, well, how are you going to test this? How are you going to validate it? Well, I shouldn't use the letter. One of the vendors says that they'll get us code in 12 months. Another vendor, they think they're going to get us code in maybe 18 months. Why? Don't wait. Things like gRIBI give us the opportunity to say, if we had multiple SR domains, color-aware SR domains, and we need to stitch routes between the two, maybe gRIBI could be an answer. Maybe we don't have to rely on waiting for a multi-year standards battle, like every other standards battle, to at least get a handle on why it matters to us or what our use case is. Use cases shouldn't be defined by vendor proposals. They should actually be defined by you guys in the labs, playing around with things and saying, this is actually going to help us scale our network. This is a bad idea. It's not going to help us scale our network. So big picture for a minute, play around in the labs. There's been a lot of presentations from a number of different vendors saying, here's how you get into the lab environment. Here's how you can stand things up. I will get a presentation out at some point that shows how these days when I do a lab, I use Docker, I use IP network namespace, and Slack Container Lab takes no time at all. But I can spin up a lab environment in less than 5 minutes, right? That's not the hard part anymore. The hard part is what configuration am I going to put onto the devices? What features am I going to enable? How am I going to connect them all up together and make them do something? And then once I've done that, how do I validate? How do I test that it's actually working? That's the magic. Standing up a lab, easy. Configuring a lab, pretty straightforward. Validating that the lab does something of value, that's all we need to get to. So, lecture over. Some references here. This is the motivation, this is specifications, etc. It's all on GitHub. If you want to get started, again, this is multi-vendor. Right? This isn't just Juniper or Arista or Cisco trying to tell you that their way is better. But all of the major vendors support this. So you don't have to wait. You don't have to be afraid. Conclusions. All right, so this is a new and open mechanism. Is it something that you're going to roll into production tomorrow? No. First question from the crowd I can predict is, does Open Daylight support this? No. Okay. It supports a range of forwarding paradigms, IP tunnels, surgical route injections, VRFs. It's not constrained by classic traffic engineering topologies. So yeah, it's not RSVP. It exists in a multi-vendor environment. And you can use this to experiment and play around. Yes, if you want to, you can still use BGPLU and you can try to establish the protocols. But play around with this. You'd actually find it's pretty useful. Cool. Now, I think I have time for questions.